Okay, 2-point charges Q1 and Q2 are separated by a distance of 15 cm as shown in the figure 10. Okay, calculate the electric potential at point A. Okay, find the electric potential at point A and also electric potential at point B. Okay, we look at A, electric potential at point A. So the question requires us to find electric potential, which is the symbol U. Symbol V. Sorry, electric potential is V. At point A, that means we just put VA. Yeah. All right, and then the following question is potential at point B. Point B, so is V at B lah. Okay, so what's the formula for potential? Potential V is KQ over R. KQ over R. The Q is using the point charge, the one who give out the electric field. All right. Look at this. Okay, electric potential. Let's say okay, in the notes I already explained about electric potential. So like if you have here, you have 3 charges. You want to find potential at A. So you just total up all the potential. If you have 3-point charges that give out the electric field, then you have 3 potential to add up. Yeah, V1 plus V2 plus V3. And each of them you need to find KQ over R, KQ over R, KQ over R. Okay, and important thing to note here is potential is a scalar quantity. Yeah, electric potential is a scalar quantity. Okay, because it is potential energy over charge is actually energy per unit charge. Yeah, so potential is a scalar quantity. So for adding up scalar quantity, you need to, for the charge, you need to insert a negative sign. If it is a negative charge, so you need to insert negative sign if it is a negative charge. Like you see Q2, Q2 and Q3 is a negative charge. You need to insert the negative sign. Okay, and then no need to draw vector because it's not a vector, it's just a scalar quantity. Potential is a scalar quantity. No need to draw any vector, and no need to resolve any x or y components. You just add up. Okay, so important thing to remember is the charge, you must insert the negative sign, and then the second thing is there's no xy component. Okay, just total up. Very simple. Okay, let's try to solve these questions. Okay, we start with question A. Okay, question A. I want to find potential at A. Okay, so potential at A at this point. All right, at this point. So all right, so we have how many point charge? We have 2-point charge, Q1 and Q2. Both of them are negative charge, so the charge you must insert negative sign because potential is a scalar quantity. For scalar quantity, okay. So okay, let's do it. Yeah, let's do it first. So VA, total potential at A, is actually just put V1 plus V2. Okay, the formula is very simple, KQ over R. So since it is V1, charge 1, so just put Q1 R1. Okay, and then the same goes to V2. It is from KQ2, from Q2, and distance R2. Okay, okay, let's substitute. Okay, wait a second. Okay, so what's the value for K? K you can find from list of constant. K is not the Boltzmann constant. Okay, not the Boltzmann constant. It is the constant for Coulomb's law. Okay, which is 9 exponent 9. Yeah, remember that. Yeah, don't take the Boltzmann constant. Take the 9 exponent 9. Okay, not the 1.38. It's 9 exponent 9. So okay, put in the value. I think okay, K actually is a repeated for, is a factor. You can factor out. So I factor out the K, 9 exponent 9, and then inside is I actually factor out become K, then Q1 over R1, and then Q2 over R2. Yeah, it seems simpler this way. Yeah. So what is Q1? Q1 is negative 40 microcoulomb. So remember, this potential is a scalar quantity. The charge, if you have negative sign, you must insert. The charge must have. Oops, sorry. The charge must have negative sign. Understand? The charge must have negative sign. Remember that, yeah? Charge must have negative sign, yeah? Must. It's a must. Yeah, must have negative sign. If it is a negative charge, okay? So, alright, put in the charge value, which is negative 40. So, remember to put the negative sign. It's very important. And then 40 micro. Micro change to value, SI unit, negative 6. Yeah, coulomb. All this you have to change to, change to coulomb. Change to coulomb, yeah? So, exponent negative 6 coulomb, and then divided by distance. How far is it? How far is Q1 from A? Q1 from A is 5 cm. 5 cm is how many meter? Many people divide by 1000. Divide by 1000 become this one, 0.005, which is wrong. Yeah, remember, 1 meter is just 100 cm. It's not 1000 cm. Understand not? Yeah. Many students confused about this because the 1 kilogram is 1000 gram, like that. Yeah, so they confuse. It's 1 meter is just 100 cm. It's not 1000 cm. Yeah, so 5 centimeter is just divide by 100, not divide by 1000. So divide by 100 is 0.05 meter. Okay, so this is, yeah, this is wrong, this is right. Yeah, divide by 100, not divide by 1000. Okay, so all right, so this R is 0.05 meter. Need to change to meter. All this you need to change to meter. Yeah, change to meter. So 0.05 meter. Okay, R don't have square. It's not a scalar quantity. The R don't have a square. If you talk about force and electric field, the R got square. But for scalar quantity like potential and potential energy, work done, the R has no square, no R square. It's just R only. Yeah, look at the formula. Yeah, look at the formula carefully. Be careful with the formula. Maybe go back to this one. You see that? What I'm saying is this one. You see, for force and electric field got R square, but for potential and potential energy, the R doesn't have a square. You see that? Be careful. Yeah, the R doesn't have a square. So be careful. Okay, so just 0.05, no square. And then following the Q2 is negative 30. So remember, also need to put the negative sign. Remember, for potential and potential energy is a scalar quantity. The charge must have sign. Only the force and electric field, which is a vector. When you calculate the magnitude of the vector, the charge no negative sign. Ignore the negative sign. Understand? For force and electric field, the charge ignore the negative sign. But for potential and potential energy, the charge you must have negative sign. That's the difference between a vector and scalar. Okay. All right. So okay. So for Q2 is negative 30. So negative 30 micro is negative 6. Okay. So divided by how far is Q2 from A? Q2 from A is 10 cm. So divided by 100 is 0.1. It's not 0.01. divide by 100, not divide by 1000. So it's 0.1 meter. Change to meter. Yeah, divide by 100. Okay, so in the end, let's calculate. Okay, let's calculate negative 40 exponent negative 6, and then divided by 0.05, then plus this one again, negative 30 exponent negative 6 divided by 0.1. Okay, and then multiply by 9 exponent 9. The answer is negative. This one you have negative sign. Okay, negative 9.9 exponent exponent 36 exponent 6. Okay, the unit is volt. All right, so am I right? Is the answer correct? Yes, negative 9.9 exponent 6. That's right. That's correct, the answer. Okay, now going okay, this one go to the other side. Oh, wait, let me see. Okay, now let's do B. Let's do the B, question B. Question B. So I got already the potential at A. That's potential at A. Negative 9.9 exponent 6 volt. Okay. No resolve X or Y component. Just total up. Yeah. The charge must have negative sign. Yeah. That's for scalar quantity. Now for potential at B. So again, scalar quantity. The scalar quantity, the charge must have negative sign. So do the same for point B. Okay, also V1 plus V2, because we have 2-point charge. 2-point charge, so you must have 2 potential there. Yeah, added up. KQ1 over R1, KQ2 over R2. You see, no resolve X or Y component. You can factor out the K. All right, so K is 9 exponent 9. And then again, the charge is a negative charge, so you must put a negative sign. For scalar quantity potential, you must have a negative sign. But for vector like force and electric field, no negative sign. Yeah, ignore the negative sign for charge. But for the direction, for the force and electric field, the direction, you use positive negative sign to represent the direction. Okay, so okay, now for this charge, okay, again the same charge also, yeah, from Q1 and Q2. So this one also negative, negative 40 exponent negative 6 coulomb divided by, okay, for Q1, how far is it from B? You need to find out the distance Q1 to B and then also Q2 to B. Understand? Q1 to B and Q2 to B. So Q1 to B is how far? We take this 10, 13. Oh, so you need to do Pythagoras theorem. You know, Pythagoras theorem. So this one should be 10 square plus oh, this one is in centimeter, so you need to change it. All right. Okay, I think I can maintain in centimeter first, then we change to meter later on, isn't it? Okay, so let's do it. So this one should be 10 centimeter. Yeah, it's 10 in centimeter plus 13 square. So what is this here? 10 square plus 13 square, which is again, yeah. 10 square plus 13 square, and then I insert it. I got 16.401. This is in centimeter. So I change it to meter. So the distance of Q1 to B is 16.401. I can divide by 100. Okay, not divide by 1000. Divide by 100. So change to meter. Remember, change to meter. 0.16 divided by 100 is 0.16. 401 meter. No square. No square. Okay, divided by 100. I change to meter already. And then plus, and Q2. Q2 is also a negative charge, so we must have a negative sign there. Negative sign. So it's a negative 30 exponent negative 6. Negative 6 column, and then divided by. Okay, how far is the Q2 to point B? It's 13 centimeters. So change to meter. Change to meter is 0.13 meter. Okay, divided by 100, 0.13 meter. Okay, so I can calculate the value. Very simple. Yeah. Let's calculate. Negative 40 exponent negative 6. And then divided by 0.16401, and plus the negative 30 exponent negative 6 and 0.03. Okay, multiply by 9 exponent 9. So the answer is negative 4.272 exponent 36 exponent 6 volt. That's the answer. Okay. Oh, it's a lot of difference. Why is it? Let me figure out. Yeah. So I think the answer. Okay. Something wrong. I know where I'm wrong. This is actually not 10 centimeter. So I have made a careless mistake. This is not 10 centimeter. From Q2 to Q1 is 15 centimeter. So this is where I gone wrong. So this is actually 15 centimeter. 10 plus 5 is 15. So this is 15. This is 13. So what is this? So okay, so I need to make some corrections. So last time I put as 10. It should be 15 actually. Yeah, 15. So this one should be this one I should put 15 square instead of 10 square. So 15 square plus 13 square, it is okay, and then the answer is this one should actually equal to 19.8494 centimeter. Yeah, 19.8494 centimeter. So okay, so this one is not 0.16. It's actually 0.19 0.198 is enough. Yeah, meter. Okay, 0.19. So this centimeter change to meter. So 0.19 divide by 100. 0.1985 meter. Okay. So alright. So what's the final answer? So the final answer is actually should be. Let's calculate again. Negative 40 exponent negative 6 divided by 0.1985, and then plus negative 30 exponent negative 6. Okay, and then divided by 0.13. Okay. Okay, let's calculate and then multiply by 9 exponent 9. So the answer should be negative 3.89. 3.89 exponent. It should be 3.89 exponent 6 volt. Okay, so is that correct? Yeah, finally the answer is correct. Okay, so my mistake, yeah, last time. Negative 3.89 exponent 6 volt. So that's the, so be careful with the mistake, yeah, be careful with all these potential mistake, yeah. It's actually 10 plus 5. It's not 10 only, yeah, it's 10 plus 5. So this is one example of a careless mistake student might make, yeah, like me. So I hope that you don't be like as careless as me, yeah. All right, so okay, see you in the next video. Bye.